Well, guys, the moment has arrived. Well, almost, at least at the time of this recording. All of SN8's static fires, at least as far as we know, are complete, and the vessel is ready for its historic 15-kilometer hop into the South Texas sky. And regardless of what happens, it's going to be a hell of a show. Now, even the optimistic Elon Musk has said that there's only about a 1/3 chance that SN8 is going to successfully land as they have planned. And that's some pretty good odds, I would say. Perhaps a little optimistic, but if I were Elon, I'd probably say that too. But the fact of the matter is, this is only the beginning. So much time has passed since that historic night when Elon rolled out the first prototype of the Starship, and yet, when we come to the end game, to the colonization of Mars, so much has yet to be done. I mean, we can't even say for certain that this thing is going to be able to land properly on the red planet. Perhaps it'll be able to do this on Earth, but on Mars, as I pointed out many times, maybe not. And what about the other aspects, like human transportation? I mean, there's quite a lot of steps between that hop we were just watching and this. The transportation of large numbers of human beings to colonize the red planet. And of course, I've talked a lot about that, alternative methods of landing, of arriving there, different types of ships, etc. But let's say all of this is successful. Well, as we all know, Elon is not satisfied with that either. He doesn't want to just colonize a planet that is inherently hostile to the human species, a planet where we can't breathe, where there's no liquid water, where it's too cold, where we're going to have to wander around in environmental suits. No, as we all know, he doesn't want a red planet in the long run, but rather a smaller twin of Earth, or perhaps something very much like it. And as we also know, Elon is not a very patient guy. He wants to terraform Mars quickly, and he wants to do this by dropping thermonuclear weapons over the polar ice caps. And all of us have heard about this. Some of us may be wearing t-shirts that say precisely that. But doesn't this seem a little bit nuts? I mean, first of all, where's he going to get the bombs? And then what's the point? Yeah, I know. Evaporate the CO2 in the polar ice caps and create an artificial atmosphere. But a recent study from NASA shows that there isn't enough CO2 bound into the soil of the entire planet to accomplish this. So isn't the idea actually pretty crazy after all? Well, although the solution is a little extreme, the concept is not. And I'm going to demonstrate exactly why that is the case and how mankind might be able to terraform Mars in a reasonable amount of time in just a few minutes. Good evening, and welcome to another episode of the Angry Astronaut. I am coming to you from the basement of my father's house in Colorado with no background, no props, no nothing except my sunglasses and one of my pieces of merch, which you can't even see really, but I think you can probably guess it's my Olympus MONS hoodie. But enough of that. Let's talk a little bit about the subject that I just introduced. I haven't done a video about the terraforming of Mars at all in the year or almost a year that I've been running this channel. And it's a subject that I've avoided for reasons that I can't even begin to understand, really. I mean, it's a big, big deal. As we come close to the 15-kilometer hop of the Starship, and it may indeed have already happened by the time I finally release this, that's just the first step, obviously. We have to get the Starship into orbit. We have to get the Super Heavy functional. We have to get it consistently functional for low Earth orbit activities, and then maybe to the moon first, or maybe straight to Mars. Hard to say. And then it has to be proven to be safe for humans. So many steps before even the smallest colony can be established. And then we move on to the whole topic of terraforming Mars, which seems impossible to so many people, at least from a practical standpoint, something that would take thousands of years if we were lucky. And Elon Musk has a lot to talk about when it comes to this subject, and it's probably the most controversial thing that he's ever talked about. Well, one of the few anyway. And that comes to exploding nuclear weapons, very large nuclear weapons, over the north and south polar ice caps of the red planet in order to melt the ice, to melt the carbon dioxide primarily, in order to essentially kickstart a greenhouse effect, to create an artificial atmosphere. And he's been widely criticized for this. A lot of people have called him crazy. But is he crazy? Well, NASA would say so. Just a couple of years ago, they came out with a study that proves conclusively, at least as far as the media is concerned, that this is impossible, that terraforming Mars with our current technology is simply something that simply isn't going to happen because there isn't enough CO2 in the polar ice caps and indeed even in the soil of Mars in the regolith if we were able to evaporate all of it in order to create an atmosphere. And so perhaps in their point of view, although they have yet to say it, Elon Musk's idea is crazy. But is it? And are there other ways of doing this? Well, the answer is yes. This isn't beyond our capabilities. This isn't thousands of years in the future. This is something that we could do. Maybe it would take us a couple of centuries, but if we really put our minds to it and approach the matter from many different avenues rather than just one, rather than just nuclear weapons, approached it from a lot of different angles, and there are a lot of different ways to do it, I'm confident that we could be successful. And those who come out and say that the whole idea is impossible and couldn't be done for thousands of years, I have to admit, that pisses me off more than just about anything else. And so I'm going to tell you exactly why it pisses me off right now. So here's Mars terraforming in a nutshell. First, you introduce enough greenhouse gases, mostly CO2, to warm the surface of the planet to where liquid water can form. At that stage, pressure and temperature would no longer be a danger to human life. You could just wear an oxygen mask, and then plants could be introduced, starting off with lichens and mosses, and eventually graduating to something that creates an oxygen-nitrogen atmosphere, exactly like we have here on Earth. Of course, this is easier said than done, but as I said before, not impossible. Not at all. Now, as I said before, the reason that NASA says that we can't go from the image on the left to the image on the right is because there simply isn't enough CO2 bound into the surface of Mars. There just isn't. Not in the polar ice caps, not even bound into the regolith of the planet. And so, a couple of years ago, all the news agencies came out with things saying, sorry, Elon, scientists say it's impossible, blah, blah, blah. But what I find to be strangely hypocritical is the fact that the very same scientists who say that human civilization can create a runaway greenhouse effect on this planet, which has a much, much larger environment, cannot create a runaway greenhouse effect on Mars. It seems absurd, actually. I mean, seriously, if we can create a runaway greenhouse effect on this planet that will destroy the human species, then why can we not do the same thing to Mars? Well, the fact of the matter is that we can. We just have to use a multi-tiered approach to the problem, much as how we're creating a greenhouse effect here. And this, of course, means we would have to use a lot of different methods at the same time. So let's start off with the first part, melting the polar ice caps. Now, instead of all the complications of using thermonuclear weapons, I prefer the method of using a mirror 100 kilometers in diameter to focus the sun's energy onto the ice caps, much the same as solar thermal propulsion, which I discussed in our previous episode. Now, the scientists who advocate for this process claim that it would take about 50 years in order to completely melt the ice caps, but how the hell do you build a 100 kilometer in diameter mirror? Well, you've seen this before, the origami-like solar reflector. Instead of using it for collecting solar energy, you use it to reflect the very same energy, and this technology is currently being worked on by Brigham Young University. And you're about to see another diagram that I've used before in terms of how many of these could be carried by one starship. But still, it's a very tall order. 1,000 starships launching once a day would take a full year in order to be able to deploy enough of these to be the equivalent of a 100-kilometer mirror. Then again, according to Elon, it's going to require 1,000 starships at least in order to transport enough people to build a self-sustaining colony. So what do those 1,000 starships have to do in the 2 years in between launch windows? Why not build these mirrors? I would say it would be an extremely productive use of their time. However, there's even better ways that are currently in development, such as SpiderFab, as you see here, that's currently being developed by NASA and has just reached stage 2 of its development process. And it involves 3D printing a reflective lattice work, manufactured preferably out of some kind of carbon fiber, but it could use some sort of lightweight reflective aluminum instead, in order to create giant structures without nearly as much mass, nor requiring nearly as many Starship launches. We're looking at orders of magnitude better than the origami solution that I was showing to you earlier. Now, such a structure would serve many purposes for the Martian colonists besides just melting the ice caps. For example, you could redirect a small amount of the solar energy onto solar collectors to generate power for the Martian colony. In addition, reflected sunlight in short controlled bursts could be used to power light sails from Mars to Earth or to other destinations throughout the solar system at tremendous rates of speed depending on the size of the solar sail. And I've talked about this in other videos, but nevertheless, a 100-kilometer mirror would be the ultimate power source for a solar sail. But still, as I've mentioned before, melting both polar ice caps would not create enough CO2 for our purposes. It would only be about 5 to 7% depending on who you talk to. So wouldn't this just be a waste of time? Well, it depends on what else you are doing simultaneously. Now, as was pointed out in Mars Direct 3.0, many of the cargo starships are going to be carrying almost nothing but solar panels in order to generate methalox fuel on Mars. Now, what happens when we no longer need methalox fuel once the colony has been created? The same system could be used to create methane in tremendous quantities, and methane is a greenhouse gas that is 10 times as potent as CO2. Now, in conjunction with this, we humans have also proven that we are extremely good at creating greenhouse gases in massive quantities and pouring it into the atmosphere. We're very, very practiced at that. Now, of course, Mars doesn't have substances like coal in order to produce these greenhouse gases, but it does have a lot of greenhouse gas locked up in its soil, and not just CO2. As I've mentioned before, there's methane, there's nitrogen, and a variety of other types of greenhouse gases that if we had giant plants that were powered either by nuclear power or vast solar arrays could produce enormous amounts of greenhouse gases, far beyond the CO2 that the scientists at NASA were talking about previously. It wouldn't be enough on its own, but combined with melting the ice caps, we start to get closer. Now, at the same time as we're polluting the hell out of the atmosphere, we could also use a substance called silica aerogel, and a lot of you folks have probably heard of this, but it could be manufactured on Mars. Mars, like Earth, has a lot of silica in its crust, and this could be laid down in simple carpets across the Martian surface, beneath which would be warmed sufficiently by the sun in order for photosynthesis to begin. Now, if you laid it down in carpets, you'd have to use mosses and lichens, but if you built huge biodomes like this, you could get a lot more ambitious with the types of plants necessary to produce an artificial atmosphere. Now, believe it or not, a silica aerogel biodome like the one you're looking at here would have enough solar energy to warm the environment within, to create all the plants, the trees, the thriving environment that you're looking at right now. And you could do it without any other power, just the power from the sun and the silica aerogel. So you could terraform small areas of Mars while you were also laying down carpets of the same substance with lichens and mosses beneath in order to produce even more atmosphere for the planet. And you could do all of this in conjunction with other projects. The aerogel also provides significant protection from cosmic rays and radiation, but still, anybody living within these biodomes would probably want additional protection, like the 3D printed habitats I always talk about on this channel, or simply living beneath the ground underneath the biodome, coming up only to tend the plants and to make sure that all the machinery was functioning properly. Now, in addition to this, very aggressive Martian colonists might want to bombard the planet with comets and C-class asteroids, which contain a lot of water. Now, there are some drawbacks to this. There are over 600,000 craters on the surface of Mars, most of which were probably created by C-class asteroids or comets, and yet it hasn't created much of an atmosphere, and this would be a very damaging process to the planet. As I mentioned before, Mars has a very long history of extreme impacts. Some of the craters on Mars are hundreds of kilometers across, and the geological impact of these things were catastrophic at the time when they occurred. So how large of a comet or an asteroid should we use to smash into the planet? Especially if we already have a colony there, as we probably will at that point. And besides that, Mars is a lot more geologically active than we thought. There are probably magma lakes underneath the ice caps and perhaps other places as well. There are quakes that take place on Mars on a regular basis, as was discovered by the InSight lander a couple of years ago. What would the impact be of bombarding this planet with large comets and asteroids for a period of time? Frankly, I would prefer not to find out. At the most extreme, I would advocate using asteroids that are maybe 100 meters in diameter or something along those lines. Large enough to get through the atmosphere, but not huge enough to create titanic explosions. A nuclear-sized explosion from an asteroid might be okay if we kept it restricted to a certain area of the planet, but in my opinion, that's about it. But when it comes to using less radical methods like plants and lichens, as I've talked about before, one thing that's brought up all the time is perchlorates. Perchlorates cover the surface of Mars at least a meter down into the regolith, if not more, and it's poisonous not only to most forms of plants, but also to a lot of forms of bacteria. Well, what if I were to tell you that there are a wide variety of bacteria that could not only survive in the perchlorates, but actually use it to create an atmosphere? As a matter of fact, to a limited degree, we have probably already done this. As most of you know, way back in 1976, Dr. Gilbert Levin and his team on the Viking lander carried out what was called the labeled release experiment on both Vikings 1 and 2, releasing nutrients into the Martian soil to see what would happen. If there were any bacteria in the soil, they would release CO2 and methane, and that's exactly what happened. Now, even though the Viking lander did not detect the presence of organic molecules, the Curiosity rover, which had more sensitive instruments, did, strongly indicating the presence of organic life on Mars, and the increased pressure, or presence rather, of methane and oxygen in the atmosphere continues to strengthen the idea that there is life on Mars, and widespread given the fact that the experiments were identical at both Viking 1 and 2. And believe it or not, there are bacteria here on Earth that can actually consume perchlorates and produce oxygen as a byproduct. Remember when I said that there's an unusual amount of oxygen in the Martian atmosphere? Might there be bacteria there that are devouring the perchlorates and producing oxygen as a byproduct? Why not? So what we might have on Mars, and if not, we can introduce it, bacteria that are more than happy to produce greenhouse gases for us across the entire surface of the planet if we simply give it the nutrients. And what kind of nutrients are we talking about here? Well, why not the leftovers from a colony of 1 million people? All of their waste product, perhaps some of the mulch and compost from all of the plants that they're growing. So many options to feed these bacteria. And the more that we feed the Martian bacteria, the more it's going to reproduce, and the more carbon dioxide and other greenhouse gases it's going to emit. A completely natural way of us creating an atmosphere on the Martian surface, just like bacteria created an atmosphere on our own planet. So let me tell you what I think about that NASA study. Who gives a damn how much CO2 there is in the Martian environment, in the Martian soil? We can create more through natural and artificial processes. And in some cases, Mars may be more than happy to help us if life is as widespread as all of these tests seem to suggest. And I strongly believe that the Martian bacteria and Martian life is more than willing to help us create an environment similar to what it used to live in billions of years ago. So, as I'm about to explain in my closing remarks, achieving this for Mars is not going to happen through one method, through using nuclear weapons on the poles alone. That will not work, but a multi-tiered approach using a variety of avenues will, and in a realistic time frame. But the first step is to dismiss the notion that scenes like this are impossible, that they belong to the ancient past and can never be brought back. We humans have achieved incredible things with our current technology, in some cases to our detriment, and yet for Mars, we can create a second home for the human species if we just have the courage and the innovation to do so. You know, I talk a lot about thinking outside the box on this channel, a hell of a lot. And once again, with this study that NASA came out with a couple of years ago, again, they were not thinking outside the box. They looked at one fact, and we're not even sure that it's a fact, that there isn't enough CO2 bound into Mars in order for us to create an atmosphere. They looked at that and nothing else. And there are so many other ways, as you've seen the video, that we could accomplish the terraforming of Mars and making this planet habitable. Would it be easy? No. Would it require a lot of different approaches? Yes, I think actually that we should use most, if not all, of the solutions that I've talked about in this video in order to achieve the desired results. The hardy plants, the extremophile bacteria, the use of silica gel, the use of perhaps some kind of smaller asteroids, C-class asteroids impacting the Martian surface. Although I have to admit, utilizing extreme methods in order to artificially generate an atmosphere is something that does concern me. When it comes to nuclear weapons or extremely large comets, that sort of thing. And that's one of the reasons why I decided to wear this. Mars had a very active volcanic past. And the more we learn, the more we've determined that Mars is still active from a tectonic standpoint, and most probably still has magma lakes beneath its surface. It seems like a very strong possibility. So, bombarding this planet with large comets or large nuclear weapons, in my opinion, is playing with nature, playing with this planet that might decide to fight back. And when an alien world fights back against our puny attempts to colonize it, who knows what the consequences might be. I tend to respect Mars a little bit more than that. And in my opinion, we should try to use a variety of different approaches to achieve terraforming this world and making it more like it was. And we don't have to do it violently. We may even be able to use some of the life that's currently there. And you've seen from the video that I strongly believe that there is life there. And if given a helping hand, it might be able to help us achieve our goals and return Mars to the state that it used to be in a couple of billion years ago, when this very same life, or something very much like it, might have thrived on Mars along with a variety of other kinds of life. Once again, we're not going to know until we go in person and study all of this. But I hope that this video has convinced you that the idea of terraforming Mars is far from crazy. I do think that using thermonuclear weapons is an extreme solution, and we should be looking for other solutions to the problem. But still, terraforming the planet, yes, we can do it if we think outside the box and we aren't afraid of the challenge. So until the day comes that we're not afraid of the challenge, then I urge all of you to stay angry about space.